Okay, so to record this now, forgot to do that. Our warm-up for today, the opposite of squaring is square root, the opposite of cubing is cube root, and now we are on the actual notes. Here we go. You will need a calculator, so just FYI. Now, for the notes, we're doing 6.4 and 6.5 combo, okay? The only difference, well, I don't want to say it that way. One has to do with squares, one has to do with cubes, so it's only a slight little change there. So if you see here, these are our 4 steps. Step 1, you want to isolate the radical, and do you all know what a radical is?
Yeah.
Okay. Now, in math, it looks like this, and you want to make sure there's a radical by itself on one side of the equation. Step 2, you're going to square or cube both sides of the equation to eliminate the radical. Step 3 is solving for x, and step 4 is to check for extraneous solutions, which are solutions that do not satisfy the original equation. We'll talk about all that today. 4 examples, here we go. Example number 1, okay? Let me make this bigger. Example number 1, is the radical by itself on the left-hand side? So there's nothing in front of it to the left, there's nothing after it to the right, before the equal sign. So that radical is by itself. Step 1 is good. Step 2, we need to get rid of the radical by doing the inverse. Now, from our warm-up, think about it. What's the inverse of a cube root? Cubed, okay? Cubed and cube root are back and forth opposites. Square and square root are back and forth opposites, okay? So everybody write this down. You're going to take that original equation, and to get rid of that radical, that cube root, we're going to cube both sides. Does everyone see that in the red there? So the original is the blue, but I'm going to put cubed on both sides so I can do this. Watch. Scratch that out. Scratch that out. Cube root and cube go away. And now I'm left with just 5x plus 2 on the left. Now, on the right side, the way you say it is 3 cubed. Now, it's already on there, but here's what I would imagine would happen. If I asked you, what is 3 cubed, someone would say 6. That's adding. No, okay? If I ask you 3 cubed, someone would say 9. That's multiplying. That's not it either. Do you know what cubed means? What does it mean? Not going to, but it's how many times you multiply the same number times itself. So 3 cubed doesn't mean 3 times 3. It means 3 times 3 times 3. There are 3 3s that you're multiplying. Okay? So let me highly suggest, and let me pull this up here. Let me highly suggest that you use your calculator. Okay? If you're not sure, or if you want to check yourself, please do check yourself. 3 caret 3 is not 6, it's not 9, it's 27. Because what's 3 times 3 times 3? 9 times 3 is 27. Okay? So it's very important that y'all know how to do. I don't want y'all to miss little things like that. So please, calculator can help you out. Please don't make little mistakes. Now, so that's why I got 27 on the right-hand side. Now, could you solve this 2-step equation? I would be very depressed if you couldn't, because that means I failed as an individual, as a teacher, and in general, I should be revoked of my Teacher of the Year status and probably fired and live on the streets begging for change. Okay, so no pressure, but how do you solve this thing? What do I get rid of first? The 2, because it's the loner, right? How do I get rid of that plus 2? Like literally, the one thing you don't touch is the x. Okay, so to get rid of a plus 2, what do I do? Minus 2 on both sides. Okay, cancel out on the left, right? And then what's 27 minus 2? That's not a trick, it's easy, 25. Last step, 5x. Now 5 and x are being what if they're just next to each other? They are not best friends. What? Okay, so 5 and x are currently multiplying, so to get rid of them, we do divide, okay? So it's called a coefficient, and you get rid of any coefficient by dividing. So divide both sides by 5, and we get 5. Yes, okay? Now, the solving a two-step problem should be old news, easy peasy, but the first couple steps is the new thing. Well, it'll be all right. But does everyone understand? The first step to get rid of the radical is the opposite, the inverse. So if you have a cube root, you cube it. What if it was a square root? Square it, okay? Okay, it's the opposite of whatever the root is. Square root, you square to get rid of it. Cube root, you cube to get rid of it. And please use your calculators if you're not sure about these exponents. Now, example 2, which allegedly looks scary, it's not that bad. Let's talk about it. Step 1 is the radical by itself? So I see a cube root x, but in front of it, I see two things, a 5 and a 3. So what do I need to get rid of first? First, which one would I get rid of? Okay, the loner, which is the 5 by itself, okay? It's a positive term, so how do I get rid of that 5? Hey, subtract 5 on both sides, right? Because it's a positive term, right? You want me to write you a letter or something? Okay, so what's 20 minus 5? 15. Boy, howdy. Now, in this equation, you can see the dot already there, but usually it's not there. Usually it's just a number in front. And I would ask you, what's happening between the 3 and the cube root x? What operation? It's already there, but what's happening between 3 and cube root x? They're multiplying, so how do I get rid of it? Divide. Okay, so divide by 3 on both sides. 15 divided by 3 is what? Someone said 5. Now, is the radical by itself now? Yes, it is. So, step 1's good. Now our step 2 is we need to get rid of the cube root by doing the inverse operation. What's the opposite of cube root? Cube. Just like we did on example 1. So to get rid of the cube root, both sides get cubed. Get this down. Cube both sides. Now that's going to cancel the cube root and the cube, so now we just have x. Now, what's 5 cubed? Who thinks it's 8? Because you added 2 numbers. That's definitely not it. Who thinks it's 15? Because you just multiply 5 times 3. That's very wrong. Okay, 5 cubed means 5 times 5 times 5. It's not 15. I didn't say 5 plus 5 plus 5. I said 5 times 5 times 5. So please use your calculator when you get to this point. Okay. It's 125 because you did 5 times 5 times 5. 25 times 5. So you don't have to do any of that mental math if you just type it in your calculator correctly.
That would be nice if we could use that math.
It would be. So 5 caret 3. Now, that's 6.4. We're halfway through the notes. Now, here's the deal. Here's the dealio. On the back side, so you can flip it over to 6.5 side. We're going to just knock this out real quick. 2 more examples. What's going to be different? What's going to be different on the back is that we need to be able to find extraneous solutions, okay? It's annoying, it is what it is, okay? Now let me tell you, when you're writing this stuff, in each space, you want to like have some room, at least for 2 columns. You're going to write some stuff, and then you're going to check some stuff, okay? So don't write huge, is I guess what I'm saying. Okay, here we go. Now, this, let me tell you, I was gone, not last week, but like before the break, for those 4 weeks, all the other algebra classes were doing factoring, quadratics and stuff, which there was no way that you would learn that without me with the sub. So I didn't pretend to leave that for y'all. I think right before I left, or maybe one of the lessons we did on polyroots. Does anyone remember doing polyroots? You're missing information in your brain that you should have. But that's okay, because I'm going to teach you the shortcut calculator way that will take a lot less time. Okay, so what is on the screen here would be relevant if you were doing this the long way. That's more difficult. So I will spare you the suffering, and we'll cut to the chase here. Y'all ready? All right. Now, does everyone see this is a little bit different? We have a square root, but it's not equal to a number. It's equal to an x. Okay. So we're going to still do our first step. Is my square root by itself on the right side? How do I get rid of a regular square root? The opposite of square root is square. Okay. So let's go ahead and write this. You're going to square both sides to get rid of that one square root. Okay. But this is going to look different, so please pay close attention here. Okay. The left side, x squared, is just x squared. On the back, right? On the right side, the square root and the square cancel out, and you're left with x plus 2. Now, check this out. We have an x squared and an x. This is a situation in which you cannot solve for one number. Okay? So if you get in a situation like this, which you will on the assignment, where you have an x squared on one side and an x on the other, what you're going to need to do is get it to look like it equals 0. Okay? This is called standard form of a quadratic, standard form of a polynomial. So let me show you what's going to happen. I know this is about, it might sound confusing, but I know. But follow these steps. Ready? We need to get it to be equal 0. Okay? So let's take the whole right side and move it over. So how would I move over a positive 1x? What do I do? Minus an x. How do I get rid of that positive 2? Minus a 2. So check it out. If I put underneath minus x, minus 2, minus x, minus 2, you have to, I'm just telling you, you have to get this equal to 0, right? Okay. So on the left side, I have an x squared, I have a minus x, and I have a minus 2. You're just going to write them right next to each other. Boom. Okay? So far, so good. I know this is brand new territory over some stuff that we didn't get to learn when I was not here, so just follow me closely. There is a way for you to do what I'm about to show you. Now, check this out. You're supposed to turn that trinomial into 2 binomial factors and set them equal to 0 and solve them for x. Who wants to do all that? Don't worry about that. Don't write it down, because I'm going to show you how to do it in the calculator. Okay? Ready? Okay, we're going to use what's called polyroots. So now, off to the side, you're going to make these little notes, okay? Call this polyroots. Ready? Polyroots is how the calculator gives you those 2 answers at the end there. Yes, write this. Polyroots, okay? So, all right, now, so polyroots, here's the buttons you're going to press. Okay? Let's see if I can. Okay, so let me show you. So on your calculator, you're going to go to a regular, add a calculator. Okay. Now either you're doing this with me or you're watching up at the front. Okay. The buttons you press are menu, 3 for algebra, 2 for numbers. No, hold on. My menus do not match your menus, so let me look at your calculator and kind of whack that a little bit. So you're going to press menu 3, 3, 2. Okay, menu 3, 3, 2. Everybody write that on your notes. Menu 332 is going to give you something called polyroots. All right, here we go. So menu 332. Okay. When you do menu 332, you're going to get on your calculator what looks like this, polyroots. Now, in the parentheses, I'm going to type just the left side of that equation. So check it out. X squared minus x minus 2. You just can't forget to put comma x. Do y'all remember when we did nsolve? You have to always put comma x. Yep. So when you do polyroots, menu 332, you type in just the left side of that equation, forget the equal 0. Put comma x, hit enter, and it spits out the literal two numbers. Do y'all see on the notes that I scratched out? -1 and 2, -1 and 2. If you can remember this series of buttons and type it in correctly, then you will not have to do this. Now, if you want to learn this, which would actually be a good thing for you to learn, we can do that another time. But right now, I'm giving you the direct calculator way to do this. Sound good? Trying to help you because we lost 4 weeks, now 5 weeks, because meetings and babies and whatever. Baby's good. All right, now on the notes, I'm going to write what I typed. So here's what I typed. Ready? In the calculator, it says polyroots. Then we put the parentheses. We type it in, x squared minus x minus 2, comma x. We hit enter, and it spits this out, -1, comma 2. And you can see that was the answers over here. So don't forget the comma x. Is everyone hearing me elevate and inflect my voice as a remembrance that you must not forget the comma x? All right? Please do not forget the comma x, please. Thank you. All right. Also, do we type the equal 0? No. So no equal 0, put a comma x. Is that cool? Is everyone smart and got that? Okay, now, here's the deal. If that wasn't enough, okay, we have to check for extraneous solutions. Okay? Now check it out. Here's how you do it. You're going to take that -1. You're going to plug it into the original equation and see if it works. Okay, so check it out. Here's the original equation. If I plug in -1 to both of those x's, it gives me something that is not true. -1 equals 1. Okay, if you type this in your calculator, you'll get a +1. They're not equal to each other. Since they're not equal, we call that an extraneous solution. It is incorrect. So I can kind of say -1 is whack, but we're going to check the 2 and see if that one's good. So is everyone writing this extraneous solution stuff off to the right? When I plug in 2, 2 equals the square root of 4, which is 2. 2 equals 2 is correct. So my only answer that I actually get is 2. Okay? Because -1 was extraneous, it does not work. Only x equals 2 can be accepted. Whoops. Now we just did a lot, so let me backtrack. Let me clarify. Okay? So, what did I do? I squared the square root. I got it everything onto one side equals 0. Then I use polyroots, menu 332. Type it in, comma x, get my solutions. Then you need to check those solutions and then get your answer. All right? Now, one more example. Y'all ready? All right, example 4. Here we go. Now, if I have a square root on both sides, it's isolated. It's by itself on both sides. How do I get rid of those square roots? Which is squaring. So if I go ahead and write this down, right? I square both sides. It's going to cancel out the square root in the square, cancel out the square root in the square. Now, do you see how we have an x squared on one side and an x on the other side? This is that weird situation like we did on example 3, where we need to get it all onto one side. Okay, this is called a polynomial, quadratic. We're going to get everything to one side. Now, let's move over that negative 3x. What is the opposite of a negative 3x? Adding 3x to both sides. So go and do that. Plus 3x, plus 3x. And that plus 3x is actually going to go right there in the middle. Well, so here's the deal. Usually you have the squared, then the regular x, then the regular number constant. Okay, so you're kind of putting it in descending order. Well, so we're just trying to get everything off of the right side, and the right side only had that. So that plus 2 stays where it's at, because it's already on the left, right? So that 2 is already on the left. We leave it there. Now, is it equal 0? I can see it clearly is. So now what buttons do we press from here? Oh, okay. Menu 3, 2. It's going to look like this. You're going to write, it's going to say polyroots. What do I type in polyroots? Equals 0. Or, do I put the equal 0? Oh, I don't. All right, so it's going to look like this. Polyroots, x squared, listen, x squared plus 3x plus 2, comma x. If I hit enter, it's going to spit out the brackets, -2, -1, I believe. Let's try it. Shoot. All right, so menu 332, my bad. Menu 332. Okay, so I'm going to type x squared plus 3x plus 2. Now, I hit enter, I got an error because I forgot to put comma x. I goofed, so here we go, comma x. -2, -1. Do you see how to get these roots using polyroots? Now, we're not done because remember, what do we need to do with those? We need to check if they are extraneous solutions. Okay. Now, I'm going to cut to the chase here. When you plug in -1, check it out, write that down. When you plug in -1, you get something that is equal. That is a good solution. When you plug in -2, you get the same thing. That is a good solution. So like on this one, you have 2 good solutions, -1 and -2. Oops, okay. So I know this is kind of maybe an annoying problem where you have all these new steps and new things to do, but believe me, I'm saving you a lot of steps and heartache and brain power with polyroots, okay? That's scratched out, yes. I promise you that would take you, y'all can definitely do it. It's just that I haven't taught it. I don't got extra days to throw in here to teach it at the moment because we're already behind this 9 weeks. And it's Thursday. People that schedule me for 3 meetings in a row. That's good. Believe me, I was not just like sipping Arnold Palmer's at home, you know, watching Cowboys tape, you know. All right, now I'm going to give you the assignment. It's going to match.
Do we have time to do that?
Probably. 6-4 matches example 1 and 2. 6-5 matches example 3 and 4. Here we go.